Hey Pepper, can you tell me about our patient John Doe?
The radiograph shows a fracture.
I see. Where exactly is the fracture?
I have highlighted the fracture area here.
Are we sure this is a fracture, not a ligament tear?
It looks a lot like these other two fractures.
That makes sense. Alright, thank you Pepper. That should help me write up John Doe's records.
Hey, Dr. Armstrong.
Oh, hey Dr. McCullen.
What is it you're doing? It looks really interesting.
Well, we have a new explanation strategy for our AI fracture detection system, and I was just sort of testing it out.
Oh, that's really interesting. How did you build it?
You know what? Why don't I let one of the creators explain it to you?
Hi folks, I'm Kyle Martin, part of the consortium that created iSee. So, let me talk you through the iSee system and a little bit about how it works. We start by representing the query case using iSee Onto. iSee Onto is an ontology that we have built to represent AI models, user needs, different explanation strategies, and the different ways that these can be evaluated either through empirical or user evaluations. We use this ontology to create a query case. The query case is formed initially of an AI model and your user needs. What we're looking to gain from the iSee system is the appropriate explanation strategy to meet that model and those user needs, as well as an appropriate evaluation strategy. Using the query, we perform a similarity-based retrieval from the iSee case base, which stores complete explanation experiences. The similarity-based retrieval is informed by many are called, few are chosen, and this in turn is empowered by local similarity methods using techniques such as exact match, same type match, hierarchy match, or simple distance-based measures for vectors. Once we've retrieved these cases, it's time to reuse their solutions in order to inform the solution for our query case. Sometimes, if our query is sufficiently similar to one or more of the cases we've retrieved, it'll be okay for us to reuse that explanation strategy in its entirety. Other times, there might be slight differences between the query and the cases we've retrieved. And in those circumstances, we will use constructive adaptation to build an adapted case which is much more suitable to the given query circumstances. This will include an adapted solution, a behavior tree describing the different explainer algorithms and how they answer different intents, i.e. the different user needs that the specific query has. Once an adapted solution has been accepted, the design user, i.e. the person who came to us with the query case in the first place, will be able to take the explanation strategy and try it out with some of their end users. These end users will be able to describe to them, helped a little bit by the iSee system and the evaluation cockpit we provide, exactly the circumstances in which the explanation strategy helps them with their work, or where it could maybe be better. We expect this will be an iterative process. It may well be that based on the user evaluation, the design user decides to revisit the explanation strategy, either to make some manual tweaks, maybe the users have requested a specific explainer algorithm be included, for example, or they may want to revisit earlier points of retrieval and reuse to try out broader changes to the explanation strategy. Once the user evaluation has reached satisfactory levels, we can save it as part of the revised case. This allows us to have a complete case with our problem component, informed by the original query, our solution component, the explanation strategy that's been accepted by different users, and an outcome component, i.e. the results of the user evaluation. And once we have this complete query, we can retain it in the iSee case base.